Hi everyone, my name is Hendrik Beyer, and my talk today is about a vision paper I wrote with Michael Keisers at CWI in Amsterdam, proposing the research challenge of explainable search. Now, what do we mean by explainable search, and what is it good for? The basic question we're posing is, how can a search-based agent explain what it's doing and why? A number of recent major breakthroughs in AI, in particular in reinforcement learning, have involved search-based agents, in the sense of agents using online planning for their decisions. For example, the famous AlphaGo and later AlphaZero agents, which use search for learning and playing board games on a superhuman level. We're using a chess AI as a recurring example in our paper and on these slides, but of course, search algorithms such as Monte Carlo tree search are used in countless other domains as well, with increasingly higher stakes and with increasingly more autonomy, which is why explainable behavior is rapidly becoming so important for search algorithms. Now, what's our answer to this question? In abstract terms, our answer is this. Explainable search is an exploration of possible futures, their evaluations, their relationships to each other, and the available choices we have between them. Explainable search, for example the explanation of a given chess move and the reasoning behind it, means explicitly talking about what our possible actions are, to which future states of the world they could lead us, what our preferences for future states would be, and therefore which actions we prefer in which situations. This is how humans explain their actions in such complex domains, and this is what we expect from a collaborative and trustworthy AI as well. And needless to say, real search trees are non-trivial. Some people think of trees as self-explanatory because they're thinking of small decision trees with maybe a dozen nodes. But this is far from true for a chess algorithm going through many thousands of moves and possible futures every second, and constructing its complex plans from them. Explaining search is important, and it's also hard. Now, you might agree that explainable search would be very nice to have, but why do we think this research direction is novel? Why does existing XAI work not quite cut it? I'm going to strongly simplify here, so please forgive me if your own work doesn't neatly fall into this classification. But basically, we can see two types of approaches in most prior work on explainable agency. The first common type of prior work aims at explaining individual decisions of non-searching agents. These approaches, for example, highlight which input variables were the most relevant for a decision, or what the decision changes about the probabilities of certain events. However, this still leaves the user asking, why was, for example, this corner of the board important for this move? Or how does this move increase my chance of capturing the opponent's rook? What exactly does the AI expect to happen next, and how is it planning to react to it? For a sequential decision-making domain like chess, myopic explanations are a bit poor and don't reflect how humans would explain their chess moves to each other. The second common type of prior work aims at explaining entire agent policies. That means the complete set of behaviors an agent is capable of. These approaches, for example, characterize a given agent by building an interpretable secondary policy that approximates the actual behavior of the agent, or by presenting a lot of typical behavior examples in the hope of giving a good overall impression of the agent. However, looking at our chess example again, when the AI is asked for the reasoning behind a specific move, a high-level lecture on chess strategy is clearly not the right kind of answer either. What we actually need is explicit reasoning about different possible futures, the probabilities and utilities of different future events, and the behavior that is estimated to be most promising. Now, you hopefully agree that explainable search would be very nice to have, and that we need to take a somewhat different approach to get there. Now I'm going to try to outline some important research directions for the development of explainable search, some challenges we're going to have to tackle. Not all of these are completely novel or unique to explainable search, but we believe they are particularly crucial for it, and Explainable Search gives us particularly good motivation to bring them together from a new point of view. Challenge number 1. Explanations as conversations. Human explanations have been found to naturally take the form of continuous interactions, and we believe that this under-researched aspect is a must when it comes to explainable search. Because first, it's unlikely that a single explanation of a complex search can be one-size-fits-all. As in this example, you say that I should make this bishop move to defend g6, but why not use the knight instead? And second, when interacting online in sequential decision-making environments from time step to time step, we also need an ongoing interaction between AI and user in order to understand our evolving plans. For example, by asking, wasn't our plan before to increase the pressure on the opponent's rook? What has changed now? In such settings, it won't be enough to give explanations in static form, unlike maybe when explaining a neural network output, or even when explaining a fixed optimal solution to a classical planning problem. Challenge number 2. Explanations as two-way street. With this challenge, we want to highlight that in a typical online sequential decision-making setting, it's rarely possible to solve the task to optimality, and therefore neither the human user nor the search AI can generally be assumed to be omniscient. We cannot assume anymore that the purpose of explanations is simply to correct the user's misconceptions or to convince the user to accept a recommended plan. This means that explanations should actually allow information to flow both ways. In such cases, explainable search can be thought of as a joint search for optimality involving human and AI. And this brings into focus concepts such as argumentation and contestability of explanations. Challenge number 3. Explanations in long-term interactions. This slide shows an AI not simply explaining a single chess move in a vacuum, but putting it into the context of longer-term plans that span multiple decisions, and also referring to earlier explanations of such plans as it is interacting with the user over an entire game. We believe that the online setting of explainable search is ideal for focusing on user-aware, personalized explanations, because we're going to interact with users over longer periods of time, maybe within a single chess game in our example here, but maybe also over multiple chess lessons consisting of many games while tracking the user's progress. Long-term interactions mean that the user's understanding of the world cannot be assumed to be given and unchanging anymore. And we can also learn user preferences over time and aim at more long-term user satisfaction. Challenge number 4, explanation-aware search. On this slide, the AI uses its model of the user's understanding of chess in order to influence its own behavior, so as to avoid unnecessary confusion of the user. Some prior work has suggested that we could achieve something like this by, for example, considering explanations as actions with epistemic effects, with effects on the user's understanding, and directly integrating them into the planning process. For joined human-AI activities, such techniques could help avoid explanation bottlenecks, especially in time-critical domains. And as we can see in the example of the chess tutor AI, even hiding certain plans or goals instead of explaining them could have good non-adversarial uses. This goes far beyond the usual approach of simply planning as well as possible and then explaining reactively afterwards. Challenge number 5, counterfactual explanations of search. This slide illustrates that sometimes when a why not type question is asked, such as why shouldn't I move my knight to f3, we might actually not be able to find a good answer to that in the search that was done, because the knight move was quickly considered suboptimal by the search and its consequences were not explored in much depth at all. But if it's not obvious to the user why knight f3 is suboptimal, A good explanation might require exploring those suboptimal consequences in more detail and spelling them out for the user. This shows that explainable search can mean more than just explaining the reasoning process that just happened. It can also mean interactively constructing reasoning that could have happened and contrasting it to the original choices of the AI. And last but not least, challenge number 6, integrated explanations of search and learning. This example draws attention to the fact that search algorithms typically consist of two things: the search technique itself, such as Monte Carlo tree search, which walks through possible futures, and the heuristic knowledge used to guide the search and to evaluate and compare the possible futures found by the search. Nowadays, this heuristic knowledge usually takes the form of a deep neural network, which, for example, encapsulates everything the search algorithm knows about chess. In order to truly explain state-of-the-art search, we're therefore going to have to combine our growing understanding of how to explain search, or goal-driven AI, with our growing understanding of how to explain neural networks, or data-driven AI, as well. So to summarize, our vision is explainable search as an exploration of possible futures, their evaluations, their relationships to each other, and the available choices between them. This vision is going to share progress with other areas of explainable AI on many aspects. However, we believe that the unique challenge of explainable search is to create agents that can explicitly reason about these complex spaces of possible futures, which are spanned by their potential actions. And we believe that through continuously searching, communicating, and learning about both searching and communicating, such explainable search agents can become much better partners for effective human-machine collaboration and much better leverage both AI capabilities and human capabilities in solving our problems. And that's the end of my talk. Thank you very much for watching, and goodbye.